electric potential of a point in electric field. We have discussed about electric field. Electric field is important concept, and if you want to see separate video, you have to click I button upper side. Let this is plus Q charge, this is source charge, this is source charge, and this circle you are seeing is this circle is this area, this space is electric field of plus Q charge. Means what? If we put any charge, any test charge here, it experiences a force, and out of field, out of electric field, this portion, green portion, is out of electric field, means the force on test charge will be 0. If you put any test charge here, the force will be 0. Why? We have discussed earlier that force is Q0 by R square, Coulomb's law, and force is inversely proportional to R square, inverse square law. As distance increases, force decreases. So at large distance, the force becomes 0 and out of field. Now let this point is P, and we have to determine electric potential of this point. We try to bring this charge inside electric field, then this plus Q charge exert a repulsive force F, this, and opposes the movement of charge inside the field. Due to this opposition of field for movement of plus Q charge, work is required to, we know that if we want to move charge against this force or field, work or energy is required to push this side, whereas force act opposite on plus Q charge. This work done, let for Q0 the work done is W, any amount of work. So for plus 1 Coulomb charge, if you want to bring plus 1 Coulomb charge from outside, outside means for infinite to inside at any point, let this distance is R, we have to do work. So if Q0, the amount of work is W, then for plus 1 Coulomb charge, the amount of work will be W by Q0. And this is potential of that point and stored in point as energy. If you release this charge, it will move away automatically due to this additional energy. So electric potential of point P in electric field is amount of work done in moving plus 1 Coulomb charge from outside field, means from infinity to that point. So potential of P is work done upon charge. Its unit is 1 volt, and 1 volt is 1 joule upon 1 Coulomb. It means that if 1 Coulomb charge, to move 1 Coulomb charge plus 1 Coulomb charge from infinity outside to any point, the work done is 1 joule, then the potential of that point will be 1 volt. Then what is potential difference? What is potential difference? I hope that you are getting meaning of potential. If we bring any charge or plus 1 Coulomb charge from infinity to any point, the work done in bringing is potential of that point, potential of P. If we bring the same plus 1 Coulomb charge from infinity to other point, this point, let this point is M, then work done in bringing unit positive charge from infinity to this point, because this point is close to source charge, this point we have to do more work. It means that Vm is not equal to V. Vm is more than V. And if Vm is not equal to Vp, there will be a potential difference between 2 points, and this will be Vm minus Vp. So Vp is amount of work done in bringing from infinity to P, plus 1 coulomb charge. Vm is amount of work done in bringing unit positive charge from infinity to M point. And what will be the value of Vm minus Vp? That is called potential difference, is amount of work done in bringing unit positive charge from P to M. That is amount of work done upon charge, or you can say work done in moving plus 1 coulomb charge from P to M, lower potential point to higher potential point, and that energy is stored in this point as potential. This is potential difference. So both potential difference and potential of point. What is potential of point P? Amount of work done in moving plus 1 coulomb charge from infinity to that point P. What is potential difference between 2 points P and M? Amount of work done in moving plus 1 coulomb charge from P to M. Again W by Q. But here W is amount of work done in moving from P to M. Here W is amount of work done in bringing from infinity to. Now through analogy with different situation, we will try to understand about potential difference. As you are observing in our houses, we have one water tank, overhead water tank, and as we put on the tap, the water starts to flow. So water flows due to pressure difference, higher pressure to lower pressure, or higher pressure energy to higher level to lower level. This difference causes the water to flow. If they are on same level, water will not flow. In the same way, you see here is a cell or battery, and we have positive and negative. This positive end means higher potential energy or higher potential, and negative end means lower potential. From higher potential means positive to lower potential means negative charges. Which charge? Positive. Charge flows because of potential difference. Again, flow due to difference. Charge flow due to potential difference. Water flow due to pressure difference. Potential difference causes charges to move or flow and constitute current in the circuit. As you are seeing here, 12 volt battery. We have 12 volt battery. So the source of potential difference, from where potential difference is coming, source of PD is maybe a cell, a battery, or AC main as you are using in your day-to-day life. It may be a cell. So this is positive end, this is negative end, higher potential, lower potential, constituting potential difference. If you put on the circuit, current flows and bulb start to glow. Current flow from positive of battery to negative of battery. Here you can also understand that if you connect a battery from positive to negative, the electrons flows from negative to positive. This is positive end of battery because you know that electrons are of what type? Negatively charged. Positive end here, positive, this is negative. Electrons move toward positive because these are negatively charged. Electron flow direction is from negative to positive. So electrons are moving in this direction. The convention of current flow, traditional current direction, is from positive to negative. Current start to flow from positive to negative. Current flows from positive end to negative end. Electron flows from negative to positive. Current direction is opposite to flow of electrons. I hope that now you are able to understand the meaning of potential and potential difference.